measurement of current on a high voltage line can be measured by, okay, current transformer, voltage transformer, load resistor or current shunt, okay. Measurement of current at high voltages can be measured by using CT, okay. High current can be measured by using CT, okay. హై కరెంట్, ఓకే. అలాగే పీటీని యూజ్ చేసి, పొటెన్షియల్ ట్రాన్స్ఫార్మర్ యూజ్ చేసి మనం హై వోల్టేజెస్ని మెజర్ చేస్తాము, ఓకే. హై వోల్టేజెస్ని మెజర్ చేస్తాం, ఓకే. హియర్ హై కరెంట్స్ కెన్ బి మెజర్డ్ బై యూజింగ్ సిటీ, కరెంట్ ట్రాన్స్ఫార్మర్, ఓకే. నెక్స్ట్ క్వశ్చన్, ద రిలేటివ్ పర్మియబిలిటీ ఆఫ్ ఎ మెటీరియల్ ఈజ్ మచ్ గ్రేటర్ దెన్ 1, ఓకే. రిలేటివ్ పర్మియబిలిటీ, ఓకే. మనకి మ్యాగ్నెటిక్ మెటీరియల్స్ అనేవి డయా, పారా అండ్ ఫెర్రో, ఓకే. మనకి డయా మ్యాగ్నెటిక్ మెటీరియల్స్కి రిలేటివ్ పర్మిబిలిటీ అనేది లెస్ దెన్ 1 ఉంటుంది. అలాగే పారామ్యాగ్నెటిక్ మెటీరియల్స్కి రిలేటివ్ పర్మిబిలిటీ అనేది స్లైట్లీ గ్రేటర్ దెన్ 1 అనేది ఉంటుంది. అలాగే ఫెర్రో మ్యాగ్నెటిక్ మెటీరియల్స్కి రిలేటివ్ పర్మిబిలిటీ అనేది మచ్ గ్రేటర్ దెన్ 1, ఓకే. మచ్ గ్రేటర్ దెన్ 1, ఓకే. ఇన్ ద క్వశ్చన్ దే ఆర్ ఆస్కింగ్ మచ్ గ్రేటర్ దెన్ 1 అంటే ఫెర్రో మ్యాగ్నెటిక్ మెటీరియల్స్. ఫ్రమ్ ద ఆప్షన్స్, ఆప్షన్ D is the correct answer, okay. Next question, the self inductance of two coils are 4 millihenry and 9 millihenry respectively, okay. The coefficient of coupling is 0.5, okay. What is the mutual inductance between the coils, okay. We have one formula for mutual inductance, okay. M is equal to K into root L1 L2, okay. K is coefficient of coupling, L1 and L2 are self inductances, okay. M is mutual inductance. We have to find mutual inductance, okay. Coefficient of coupling is 0.5. అలాగే L1 is 4 millihenry, okay. అలాగే L2 is 9 millihenry, okay. We will get 0.5 into 36, okay. Root 36 is equal to 6. 0.5 into 6, okay. We will get 3 millihenry, okay. Mutual inductance is 3 millihenry. From the options, option D is the correct answer, okay. Next question, 1 Weber of magnetic flux is equal to how many number of magnetic lines of force, okay. 1 Weber magnetic flux, okay. We have south pole, north pole and south pole, okay. Flux flows from north pole to south pole, okay. Flux flows from north pole to south pole, okay. These are flux lines, okay. We can say this flux is 1 Weber, okay. 1 Weber means these flux lines are 10 power 8 flux lines, 10 power 8 flux lines, okay. 10 power 8 flux lines is equal to 1 Weber. 1 Weber is equal to 10 power 8 flux lines. Option D is the correct answer, okay. Next question, find the total inductance in the circuit, okay. Here L1, L2, L3 are in parallel. L1 is 10 millihenry, L2 is 5 millihenry, L3 is 2 millihenry. They are connected in parallel, okay. We have to find total inductance, okay. L total or L equivalent is equal to 1 by L1 plus 1 by L2 plus 1 by L3, okay. L1 value is 10, L2 value is 5, okay. అలాగే L3 value is 2, okay. LCM is 10. We will get 1 plus 2 plus 5, okay. Here 6, 8 by 5, 8 by 10, okay. 1 by L total is equal to 8 by 10, okay. We will get L total is equal to 10 by 8, okay. We will get 1.25 Henry, okay. 1.25 Henry, okay. From the options, option D is the correct answer, okay. Next question, in an inductor the current changes from 0 amperes to 10 amperes uniformly in 20 seconds time. The induced voltage is 2 volts. What is the inductance of the inductor, okay. We have one formula for voltage in the inductor, okay. Voltage across inductor, this is inductor, current through inductor is I, okay. This is voltage across inductor, okay. V is equal to L di by dt. Okay, here V value is given, V value is 2 volts. Okay, L value we have to find. Okay, current I is changes from 0 amperes to 10 amperes, means 10 minus 0 by 20 seconds, in 20 seconds. Okay, 10 minus 0 10. Okay, we will get 2 is equal to L into 10 by 20. 10 1 ja, 10 2 ja. Okay, we will get L is equal to 4 Henry. Okay, 4 Henry. Okay, from the options, option D is the correct answer. Okay, next question. What is the electrical degree in stator? Okay, what is the electrical degree in stator? Okay, we have one formula for electrical degree. Theta electrical is equal to P by 2 into theta mechanical. Okay, theta mechanical for stator is in circular shape. Okay, circular shape, this is stator. Okay, stator la manaku mechanical angle circle shape. Okay, this is in circle shape, mechanical angle. P mechanical is always 360 degrees. Okay, substitute here 360 degrees, substitute here P by 2 into 360. Okay, 2 1 ja, 2 180 ja. Okay, here we will get 180 into P. P is number of poles. Okay, theta electrical angle is equal to 180 into number of poles. Okay, from the options, option A is the correct answer. Okay, next question. A 250 volt DC machine shunt field resistance is found to be 500 ohms. Okay, the shunt field current will be, okay, terminal voltage is 250 volts and shunt field resistance is 500 ohms. We have to find shunt field current. Okay, I will draw the DC shunt machine. This is shunt field winding, having resistance of 500 ohm. Either it will be motor or generator. Okay, the terminal voltage is 250 volts. Okay, same 250 volts is applied across shunt field winding. Okay, shunt field winding, here we will get ISH, shunt field current. Okay, ISH is equal to V by RSH. Okay, V is 250 volts, R is 500 ohms. Okay, we will get 250 by 500 is equal to 0.5 amperes current. Okay, shunt field current is 0.5 amperes. From the options, option D is the correct answer. Okay, next question. In a wave winding of DC generator, okay, wave winding and DC generator, if 4 conductors in armature having 8 poles rotates with the speed of 600 rpm. Okay, 8 poles and 600 rpm. Okay, the magnetic flux is 0.5 Weber. What will be the magnitude of induced EMF? Okay, we have to find induced EMF or generated EMF. Okay, EG is equal to pi Z n by 60 into P by A. Okay, pi is magnetic flux, Z is number of conductors, n is speed, rotational speed, P is number of poles and A is number of parallel paths. Okay, for wave winding, number of parallel paths A is equal to 2. Okay, for lap winding, A, number of parallel paths is equal to number of poles. Okay, number of parallel paths is equal to number of poles. Okay, now in the question they are given wave winding. Wave winding means number of parallel paths is equal to 2. Okay, substitute one by one here. Flux is 0.5. Okay, alage Z, number of conductors is 4 conductors. Okay, speed is 600 rpm by 60. P, number of poles is 8 poles. Okay, number of parallel paths, wave winding number of parallel paths is 2. Okay, 2 1 ja, 2 4 ja. Okay, 60 1 ja, 60 10 ja. Okay, 0.5 into 4 into 10 into 4. Okay, 0.2 into 4 is equal to 2. 10 into 4 is equal to 40. Okay, we will get 80 volts. Okay, generated EMF or induced EMF is equal to 80 volts. From the options, option B is the correct answer. Okay, next question. Dash will be equal to the number of parallel paths in DC machine of lap winding. Okay, lap winding la number of parallel paths equal to, okay, number of parallel paths is equal to 1.5 times of the number of poles, double the number of poles, or equal to number of poles 3 times of the number of poles. Okay, మనకి DC machine లా వచ్చేసి 2 types of windings ఉంటాయి. ఒకటి lap winding, second one is wave winding. Okay, మనకి lap winding లా number of parallel paths is equal to number of poles. Okay, అలాగే wave winding లో వచ్చేసి number of parallel paths is always is equal to 2. Okay, there are 2 types of windings, lap and wave. Okay, in lap winding number of parallel paths A is equal to number of poles. అలాగే wave winding number of parallel paths is equal to always 2. Okay, lap winding is used for lap winding is used for high current and low voltage. Okay, అలాగే wave winding is used for high voltage and low current, high voltage and low current. Okay, but power rating in lap is equal to power rating in wave. Okay, both are equal. Okay, from the options, option lap winding number of parallel paths is equal to number of poles. Okay, option C is the correct answer. Okay, next question. Copper loss is proportional to, okay, copper loss is proportional to I or I square, I cube or root I. Okay, copper loss, what is copper loss? Copper loss is equal to I square R. Okay, copper loss PL is directly proportional to I square and PL is directly proportional to R. Okay, copper loss is directly proportional to square of the current. Okay, from the options, option B is the correct answer. Okay, next question. Neglecting saturation, if the current of DC series motor, okay, DC series motor increases from 10 amperes to 14 amperes, what will be the torque? Okay, మనకి కరెంట్ అనేది DC సిరీస్ మోటార్లో కరెంట్ ఇంక్రీజెస్ ఫ్రమ్ 10 amperes to 14 amperes, ఆర్మేచర్ కరెంట్, దట్ ఈస్ ఆర్మేచర్ కరెంట్. ఓకే, అయినప్పుడు మన టార్క్ ఏమవుతుంది? 1/4 times of previous torque or 1.96 times or 1.69 times or 1.8 times of previous torque. Okay, we will solve this question. Okay, DC series motor, this is DC series motor having field winding, series field winding. Here armature current IA and this is flux, series flux. Okay, same armature current will flow through the series flux. Okay, pi is directly proportional to IA. Okay, torque, we have torque formula, torque is directly proportional to pi into IA. Okay, here pi is directly proportional to armature current IA into IA. Okay, torque is directly proportional to IA square. Okay, torque is directly proportional to IA square. Okay, now current is changing from, increases from 10 amperes to 14 amperes. We can also write torque T2 by T1 is equal to IA2 by IA1 whole square. Okay, IA1 whole square. Okay, T2 by T1 is equal to IA2 is 14. Okay, IA1 is 10, 14 square by 10 square. Okay, we will get T2 is equal to 14 square is equal to 196 by 100 into T1. Okay, this we will get 1.96. Okay, torque T2 is equal to 1.96 times of T1. Okay, final torque is 1.96 times of initial torque or previous torque. Okay, from the options, option B is the correct answer, 1.96 times of the previous torque. Okay, next question. What type of transformer is used in potential transformer? Okay, potential transformer, by using potential transformer we can measure high voltages. Okay, high voltages can be stepped down to low voltage. Okay, here high voltage will be there, here high voltage can be stepped down. Okay, can be stepped down to low voltage. Okay, here low voltage, low voltage. Can we step it down to low voltage? Okay, here low voltage we can use directly voltmeter. We can connect voltmeter and we can measure voltage. Okay, here high voltage is there. From high voltage we have to step it down to low voltage. Okay, here we will connect a voltmeter and we can measure voltage. Okay, okay. Here PT is a step down transformer. Okay, from the options, option D is the correct answer. Okay, next question. The core of the 3-phase 50 Hz 11,000 by 550 volts delta star 339 kVA core type transformer operates with flux of 0.05 Weber. Okay, find the EMF per turn. Okay, EMF per turn we have to find. Okay, okay, we know the formula. E is equal to 4.44 into pi ft. Okay, this is EMF. Okay, now we have to find EMF per turn. Okay, EMF per turn. Okay, E by T is EMF per turn is equal to 4.44 into pi f. Okay, 4.44 into pi. Pi is flux value is 0.05 into frequency is 50 Hz. Okay, we will get 4.44 into 2.5. Okay, 4.44 into 2.5 is equal to 11.1 volt. Okay, EMF per turn. Okay, EMF per turn is equal to 11.1 volt. Okay, from the options, option A is the correct answer. Okay, next question. With respect to the transformer, which of the following equation is correct? Okay, with respect to transformer, okay, we have one formula. Okay, N2 by N1, okay, is equal to V2 by V1 is equal to I1 by I2. Okay, V2 by V1 is equal to I1 by I2. Okay, from the options, option B is the correct answer. Okay, option B, not B, option C is the correct answer. Okay, V1 by V2, N1 by N2, I1 by I2. Option C is the correct answer. Okay, next question. Which type of relay is generally used for protection of transformer? Okay, for protecting transformer, which relay we will use? Okay, 3-phase relay or buck-close relay or no voltage relay or under voltage relay. Okay, transformer protection ki manam buck-close relay vaadtam. Okay, buck-close relay. Okay, for internal protection of transformer. Okay, buck-close operating principle vachesi gas actuated relay. Gas actuated relay. Gas actuated relay. Okay, okay. Next question. The power factor of induction motor. Power factor of induction motor at a no load. Okay, no load power factor. Okay, power factor of induction motor at no load is equal to 0.2 lag. Okay, alage power factor of induction motor at full load is 0.8 to 0.9 lagging power factor. Okay, remember these two. Okay, power factor at no load is equal to 0.2 lag and power factor at full load is equal to 0.8 to 0.9 lag. Here in the question they are asking at no load is 0.2 lagging power factor. Option B is the correct answer. Okay, in a transformer the copper loss at off load as compared to copper loss at full load. Okay, transformer la mana copper loss at off load compared to copper loss at full load is 4 times or 2 times of or 1/4. Okay, we have one formula for copper loss. Okay, copper loss at x load is equal to x square times of copper loss at full load. Okay, now here x value is 1/2. Off load means 1/2. Okay, copper loss at off load, half of full load. Okay, off load is equal to 1/2 square into copper loss at full load. Okay, now we will get 1/4 times of copper loss at full load. Okay, copper loss at off load is equal to 1/4 times of copper loss at full load. Okay, 1/4 of copper loss at full load. Okay, option D is the correct answer. Okay, next question. Calculate the slip in induction motor having 4 poles 50 Hz rotating at 1400 rpm. Okay, we have to find slip S is equal to ns minus nr by ns into 100. Okay, nr is given, nr is 1400, ns we have to find, ns is equal to 120 f by p. Okay, 120 f frequency is 50 Hz. Okay, p number of poles are 4. Okay, 4 1 ja 4 30 ja. Okay, 30 into 50 is equal to 1500 rpm. Okay, ns is equal to 1500 rpm, nr is equal to 1400 rpm. Substitute here, 1500 minus 1400 by 1500 into 100. Okay, two zeros will cancel. Okay, 1500 minus 1400 is equal to 100 by 15. Okay, 100 by 15 is equal to 15 1 ja 15 6 ja 90. Okay, 90, 10 remains. Okay, 6.6. Okay, slip is 6.6%. Okay, from the options, option A is the correct answer. Okay, next question. A 6-pole 3-phase 50 Hz induction motor, operating speed is 950 rpm. The frequency of rotor current will be, okay, frequency of rotor current we have to find. Okay, frequency of stator is 50 Hz. Okay, number of poles is p, 6 poles. Okay, okay, we have to find rotor current frequency. Okay, rotor current frequency fr is equal to, okay, slip times stator frequency. Okay, rotor frequency is equal to slip times of stator frequency. We have to find slip. Okay, slip is equal to ns minus nr by ns. Okay, nr is given, nr is 950. Okay, ns value is not given, ns value we have to find. Okay, ns is equal to 120 f by p. Okay, f frequency is 120 into frequency is 50 Hz. p number of poles are 60, 6 poles. Okay, 6 1 ja 6 20 ja. Okay, 20 into 50 is equal to 1000 rpm. Okay, synchronous speed is 1000 rpm. Substitute here. Okay, synchronous speed is 1000 rpm. 1000 minus rotor speed is 950 into 100, 950 by 1000. Okay, 50 into 100, 50 by 1000 into 100. Okay, 2 zeros will cancel, 0 will cancel. Slip is 5% or slip is equal to 0.05. Okay, 0.05. Okay, the slip value substitute here, we will get rotor frequency. Okay, rotor frequency fr is equal to slip is 0.05. Okay, 0.05. Stator frequency is equal to 50 Hz into 50. Okay, we will get 2.5 Hz. Okay, 2.5 Hz. From the options, option C is the correct answer. Okay, next question. A 2-pole synchronous generator driven at 1500 rpm, generated EMF of frequency is, okay, we have to find frequency. Okay, number of poles is 2. Okay, synchronous speed is 1500. We have to find frequency. Okay, we know frequency is equal to Pn by 120. Okay, number of poles, P means number of poles is 2 into speed, synchronous speed is 1500 by 120. Okay, 0 will cancel. Okay, 2 1 ja 2 6 ja, 6 1 ja 6 2 ja 12. Okay, 6 5 ja 30. Okay, 25 Hz. Okay, frequency is 25 Hz. From the options, option D is the correct answer. Okay, next question. A 12-pole alternator operating at supply voltage 50 Hz. Okay, 12-pole alternator is operating at 50 Hz. Okay, then what is the synchronous speed? We have to find synchronous speed. Synchronous speed ns is equal to 120 f by p. Okay, synchronous speed is 120 f by p. 120 into frequency is 50 Hz by p. P is equal to 12 1 ja 12 10 ja. Okay, we will get 500 rpm. Okay, from the options, option B is the correct answer. Okay, next question. For a 4-pole alternator 30 degrees mechanical angle is equal to, okay, 4-pole alternator la మనకు 30 degrees mechanical angle అనేది how much degrees electrical angle ki equal. Okay, we have one formula for theta electrical. Theta electrical is equal to P by 2 theta mechanical. P by 2 theta mechanical. Okay, theta electrical is equal to P by 2, number of poles are 4, 4 poles by 2 into theta mechanical is 30 degrees, 30. Okay, 2 1 ja 2 15 ja. Okay, 15 into 4 is equal to 60 degrees electrical. Okay, electrical angle is 60 degrees is equal to 30 degrees mechanical angle for 4-pole alternator. Okay, option D is the correct answer. Okay, next question. A 60 volt lamp given luminous flux of 1500 lumens. Okay, what is its efficiency? Okay, here power rating is given and luminous flux 1500 lumens is given. We have to find efficiency. Okay, luminous efficiency. Efficiency is equal to luminous flux by input power. Okay, luminous flux is 1500 lumens, అలాగే input power is 60 watts. Okay, 1500 by 60. Okay, 0 0 will cancel, 6 1 ja 6 2 ja 12, 6 2 ja 12, 30 remains, 6 5 ja 30. Okay, we will get 25 lumen per watt. Okay, from the options, option B is the correct answer. Okay, next question. Determine the distance for 25 cp lamp from the normally placed screen in order to that have illumination shall be 5 lux. Okay, we have to find distance. Okay, we have to find distance. Okay, we have one formula for illumination. E is equal to Cp by D square. Okay, E value is given. E value is 5. Cp 25 Cp. D value, distance, we have to find a distance. Okay, D square, 5 1 ja 5 5 ja. Okay, we will get D square is equal to 5. D square is equal to 5. Okay, D is equal to root 5. Okay, root 5 value is approximately 2.24 meters. Okay, distance is 2.24 meters. Okay, option B is the correct answer. Okay.